Thank you so much for having me, that I can be here and talk about this topic. Before I get started, I would really like to take a quick picture of the audience, if that's all right. I always do that to kind of like, remember this moment. I probably will share this on social media, so if you don't want to be on this, now hide your face or whatever. Otherwise, yay, audience. Yay. Perfect. Thank you. All right. My name's Dominik. I'm a software engineer from Vienna. You can find me as TK Dodo online almost everywhere. I write a blog at tkdodo.eu, mostly about React and TypeScript. And for the last I think it's almost 5 years now, I've maintained the open source library 10-stack React Query. The quick question, who has heard about 10-stack Query before or who has used it? Yeah, this is everybody. Oh my God, that's almost everybody. Cool. That's amazing. I'm not here to talk about that today, though. Sorry. I do have a very limited number, 5 10-stack stickers. So if you want one of them, you can come to me afterwards and grab it. But I'm not here to talk about React Query today because beginning of this year, I joined the design engineering team at Sentry. And we're not working directly on a specific part of the product. Instead, we have one goal, which is to make ship happen. So we want to enable other teams to ship efficiently. So to some extent, I see myself and our team as developer experience engineers, and we really want to aim to make 2 things possible. We want to make it easy for product teams to ship the right things efficiently and consistently. And at the same time, we want to guard them towards not shipping wrong things or inconsistent things. Now, to get there, a big part of our team's job is to build a design system, a library of consistent components that are reusable with good APIs, with type safety built in, with accessibility built in, but also with good documentation, because components need to be easily discoverable so that product developers can compose them and ship the product fast without breaking things. But for the second point, we are actively working on constraints. So things like setting up TypeScript correctly, ESLint, but also having a good project structure and, of course, documentation and teaching and knowledge sharing play a role there as well. So in a nutshell, what we try to do is we try to get the code base that has grown organically over the last 10 or so years in a good shape and give people the right tools to ship things fast. Now, that means we have to touch a lot of parts of the code base regularly. Like, for example, my very first PR at Sentry touched over 900 files because I enabled the no implicit any compiler setting. It also notified, I think, every code owner that the project has. And I was really surprised that this wasn't turned on when I started. But while I did this and other improvements, I was sometimes wondering if, I should maybe test the things that I'm changing or maybe at least find out where they're used in the product. And it turns out sometimes they weren't used at all. So when I introduced the lint rules for React Query, our ESLint plugin query that will help you to not make any mistakes with the library, so really check that out if you're not using that. I got some violations and I wanted to fix them all. And one of them was this custom hook, use has profile chunks. And I was battling with it for probably 20 minutes or something, and then I got rid of the violations, and I thought, okay, now I want to see where this is used. And it turns out it wasn't used at all. And then that's when I said to myself, okay, no more. This is slowing me down. This is like I'm touching things here that shouldn't be here in the first place. I'm wasting time. We got to clean house because unused code has a real cost. It means that developers have to read and understand code that shouldn't be there in the first place, and maybe they're even trying to refactor it. Library upgrades or changing lint rules become a lot more painful the more usages we have to touch, because tools like ESLint or TypeScript, they don't care if code is used or not. If it exists, it has to be error-free. And it might even increase your bundle size if it's not properly tree shaken out, because, for example, you have a module that has side effects. So all in all, it's just a pain, and it will increase in cognitive load, and it will slow us down. And that's why I think we should care about not having unused code. So how did we end up here? Well, I like to believe that developers are generally responsible beings that clean up after themselves. But in reality, we have to be constantly reminded about the most basic forms of cleanup. And I think that we are rightfully so driven by errors, because TypeScript gives us confidence. It's one of the great features of TypeScript that it can take dependencies that used to be in our head and make it explicit in code. Like I change something over here in the code base, and it changes what the function returns, and I see the error somewhere else in the code base where I'm using the same thing. This used to be really hard on big code bases without types, with just JavaScript. So that's huge for our productivity and confidence, but it also means we've come to rely on this quite a bit. And it's not just TypeScript. It's also things like ESLint or all the other guardrails and things that we have set up in our CI pipelines. If the thing doesn't show up as red, somewhere, it usually means that we are still operating within the bounds of what is considered good practice in this code base, and we're usually not looking any further than that. And I think that's how plain and simple that code sticks around. If nobody tells us to remove it, we likely won't do it. Okay, wait a second. You might be thinking, doesn't TypeScript catch this? There's my good friend TS6133, something is declared but never used. We always see this when we forget to remove an import, and then TypeScript yells at us. So we should be good, right? Yes and no. So let's assume a simple example, contrived example. We have a React component, greeting, and a util function build name, and that util function is only used within this component. And if we remove the component, and given that we have no unused locals compiler setting turned on in tsconfig, which I think we all do, then TypeScript will tell us that this function is now unused and we can remove it, and that's great. There's nothing else to do here. But what happens if we change one tiny thing? If we add an export in front of that build name function, then TypeScript will not report any errors, because TypeScript simply doesn't do any cross-module usage analysis. If we're exporting something, TypeScript will assume that we're using it somewhere else, and it will never report an error on that. That's also why it's called no unused locals, the flag in TypeScript that catches it, but if you export it, it's no longer local. And I think that's a problem. And maybe not in this scenario, but what tends to happen a lot is that those things tend to drift apart. Maybe we'll create like a utils TS file, and we have our util there, and then we export it and import it in the component. And then maybe we have multiple places where we use this, and then some of those places remove the usage. And when the last usage is removed, we probably forget to remove the actual util function itself. And I think that's the thing, that's the easiest and most common way to produce that code, and I think we do it all the time. Now, good IDEs can help with that. IntelliJ, for example, creates an index of everything, and then it can mark things as unused in a visual way, even though it is exported. But it's still up for developers to act on that. There's nothing that enforces this. So I thought, okay, this can't be it. Like, surely someone else has built a tool for this, right? And someone else must have had the same problem. I'm not the first one to have this kind of problem. And it turns out there are actually a bunch of tools that deal with this. There are tools like tsprune or unimported that have existed for quite some time. And what they all have in common now is that they're either unmaintained or archived, and they all actually recommend using Knip by Lars Kappert instead. So what is Knip? Well, Knip is a comprehensive tool to statically analyze your code for unused files and exports and even dependencies, and it then reports them to you so that you can remove them. It is quite fast on the Sentry code base, which has around 1 million lines of code. It takes about 10 to 15 seconds. It tries to be zero config, even though in any real-world application you will probably need a bit of configuration for it. And it has a lot of plugins and also support for monorepos and autofixable. And I think that's a great sales pitch, but how does it work, right? So at its core, Knip needs two things to work. It needs to know which files are part of your project. And how complicated that is usually depends on how you've structured your application, but it can be as simple as just all the TypeScript files in your source directory. And the second thing that it needs to know is it needs to know what the entry points to your application are. Now, that usually depends on which kind of framework or bundler you're using. So if you're using something like Next.js, every page.tsx file or every layout file in your app directory would be an entry point to your application. But if we're just using something like Vite, it might just be our main.tsx file. That's the entry point to our application. And once Knip knows that, it will try to navigate the module tree starting from your entry points, and then it creates a graph of the symbols that you're using. And it will then simply report on the things that are in your project, but are not in the graph of your used modules. In this case, those two red dots that are left over. And that's pretty much it. There's not much else to it, and it works remarkably well. So the big question is, where do these two things, project and entries, come from? And how can it aim to be zero configuration? Well, in short, it tries to be smart and auto-detect what you're using with its plugins. Now, to do that, it will start at package.json and look at the dependencies that you have, and then try to configure itself according to what it finds. So if you're, for example, using Jest, you will see, oh, I see Jest in the dependencies. Well, now I know which files are the test files, and those are probably entry points. Or if it finds Webpack, then it will try to infer the production entry points from that. And for each of those technologies, it has a separate plugin, and there are over 100 plugins currently, and it's only getting more. And what the plugins mostly do is they configure those project and entry settings for you so that you don't have to. So for example, if you are using Jest, this is the config you'll get per default, where it knows which test files are the entry, because that's how Jest works per default. But it will, if it finds a Jest config file, it will also parse that and then infer the rest of the information from that. All right, enough about the theoretical part. I do have a short demo prepared, how this works in practice. This is the Sentry code base. I just had to, so it's open source, you can check it out. But I had to go back in time a little bit to a place where we still had unused stuff to show you how this works. Because right now we are on 0 violations as it runs in CI. But what we can do is, if we have like violations, we can run a pm run knip. And then it runs the knip script, and it should show us a couple of things that we can remove. I hope this works. All right, so here it shows us 3 unused exports in a file called vital cards. So what we can do now is we can just go there, open that, and yeah, we can see already like that this is marked as unused, but this is just IntelliJ doing it. So we can now go and just remove that. And then the other thing was backend cards. Can also just remove that, and then there's mobile cards, and just remove that. And what we can see is then when we do that more things will show up as unused, because now we have these locals, and now TypeScript is telling us that there are other things that we can remove. So we can do that. Now there's a function generic cards, okay, was probably used by those 3, so we can remove that as well. And then there's some more things coming up that we can remove, like there's a function, ooh, this is unused, okay, this is unused. This is, I don't know if you've ever done this, but this is so satisfying. Just you go through the code and you delete all of it. Ooh. Go away, go away. This type, who needs types? Go away. Where's some more red stuff? Another function, cool. Goes away, I guess. Ooh, some more styled components. Like, I love deleting those. Just go away. All right, more stuff. Delete, delete, delete. There's some more things. Everything red has to go, basically. This is the Knip experience. You just remove stuff. And then there are imports. Like, look at all the imports. We can just clean up all the imports. There's one more type left. Woo. More imports. Cool. Okay. Is that it? Are we done? Let's look at the file. So what just happened is that we deleted from 565 lines of code to 190 lines. So we just deleted 2/3, almost 2/3 of that file, just because there was like 2 or 3 things in there that were exported and not used that we didn't know about. So that's pretty cool. But just to be sure, let's run Knip again, because we've removed a lot of imports. So maybe This is where we usually stop, right? We just delete stuff that we know, but we had some imports. So maybe there are other things where we were the last usage of it, and now maybe there's some more. I don't know. We'll see. It's like the gift that keeps on giving. So now we have like a complete unused file, sparklines index. So there was like a component like sparkline something component, and apparently it was the last usage of this exported component. So now we can just go and delete all of that. And not only that, we have an unused dependency now too. So now we can go to package.json, and now we have this React sparklines component dependency that we used to have, but we actually didn't have it because it was unused. So we can remove that as well. And then there's the type definitions for it as well. Yep. And like getting rid of a dependency is always good, like updating dependencies these days. Ugh. I don't know if you've heard about the things that are going on with dependencies. That wasn't so nice. So now we have this function here. That's apparently unused. Okay, so what happens here, this is a bit different now. What happens is this function is marked as exported, but it's not grayed out because it still has a usage. But the only usage is within this file, right? So Knip still tells us to remove at least the export in front of it, because now it becomes a local. We don't need to export it. Nobody can accidentally like import it or reuse it if it wasn't meant to be reused. And if we remove the last usage, TypeScript will tell us now that this is unused. So that's also good. Not quite as nice as completely removing it. And the last thing was this thing here. Okay. Right. So this function was also used in our vital cards. It's now also unused. So we can remove this. And then, there's some more stuff. Like there's more stuff that keeps coming up. Okay. And then lots of imports. Ooh. Okay. What do we do after we delete some imports? We run Knip again, just to see if there's some more that we can delete. Is there some more? I don't know. Let's see. Oops. There's indeed one more. I did not delete that. I did not delete the export. Okay, cool. So now, we should be seeing is, okay, we get this message called excellent, Knip found no issues, and that is the message we want to see, because that means all the code that we have is actually used somewhere. Right. That's all I got for the demo. That's how Knip works on a real-life code base. So that was nice, removing all this completely unused code, but we didn't quite stop there, because there's this one thing that developers sometimes do. I don't know if you're doing that, if you've heard of it, it's about writing tests, right? I don't know if we write tests, but what happens if we write a test and we have a function or a component, and the only usage is the actual test, right? Then the function itself, or not even a test, might even be like a story if you use Storybook or something. But this is something that you don't use in production. So those things aren't even shown by our editors because they have a usage, but they can still be deleted, and the test itself can also be deleted, right? They're kind of like going in a circle and aren't really useful. And if that happens, it not only means we have to maintain that code, it also means we run it in CI to test it, right? That's like double the pain. And imagine if that test is flaky, then we're like rerunning all the tests because this one test that shouldn't be there is flaky and so on. So the question is, can Knip detect those as well? And the answer is yes, it can. It has a production mode that's made for this, because with production mode, it only focuses on the code that we actually ship. But that means it must also know what is a production entry point and which files in the project are marked for production compared to like normal files that we also have. And for this, it has a special syntax. It wants us to add an exclamation mark to the end of our glob patterns. That is a bit weird and takes a bit getting used to. But one of the examples from the documentation is that in this example, we would have like every TypeScript file in our source directory would be a production file, and the production entry point would be the source index TS file. And then we would additionally have normal files that are not used in production, like the JavaScript files in the build directory, and the entry point that is some script.js. And this works really well if your code base is structured like that. The Sentry code base is not structured like that. So for us, it looked more a little bit like this. And that was mainly because there's no structure on where to put test helpers and fixtures. They're just part of like the normal static directory that we have. So we needed to actually actively exclude them in the configuration from the production mode. So there is going to be a bit of more things to set up, but it's definitely worth it because there are some great leftovers that can be found with this. Just one example is that we have this get incident discover URL. There was a function that had a test, but it was not used somewhere else. And Knip found that, and we could remove the function and the test itself. And I think like easily more than like 2/3 of the usages that of the code that we removed came from production mode. So this is another investment that's definitely worth making. Okay, now I know all of this sounds like really great, and we were able to remove a lot of that code. But since this is a real life story, we have to acknowledge that there were also some problems, and not everything was perfect. And there were definitely some limitations that we ran into, and I want to quickly share them with you as well. The biggest thing was definitely that it influences how we work. Now, Sentry has hundreds of developers that contribute regularly to the code base. So any small change in how we work can be potentially disruptive. And one thing that I've seen happen over and over in the code base is that some code gets added and merged that doesn't have a usage because we plan to use it in the future in a PR that comes a bit later. Now, of course, if you have Knip running in CI, this doesn't work quite well because Knip will report on those, right? One PR that I made got closed because I wanted to, I found some code that was, I think, 6 months old. And I thought it's dead code, so I removed it. And then I got called out that this is just, it is a leftover, but it was just deprioritized in the product, and they're still planning on using it in the future. Now, of course, if you run Knip in CI, this way of working doesn't really work well. You can opt out some files in the Knip config with an ignore setting, or you can add even a JS doc comment, and then Knip will leave those alone. But I think the better approach would be to always ship code that's actually used, like complete vertical, and maybe hide it behind a feature flag. Because eventually, if you keep this comment around, it will prevent this function from actually being reported once it might become really unused. Another tendency that I've seen is that some people just write export in front of everything. I don't know if that comes from copy pasting, or maybe it comes from AI, or because we think we have to do that. But then what happens is that you do this, and then you push your PR, and then Knip reports it in CI, and then you go back and you change it, and you push it again, and all of this creates kind of like a slow feedback loop that can be a bit annoying. And there's also no editor integration for Knip yet. I've heard some things that this might be on the roadmap, but it doesn't exist yet. So to address this, we've created an optional pre-push hook that people can opt into to run Knip before they push on their machines. But if you don't want that right now, you have to wait on CI to report it. And another thing that I've seen that can be quite tricky is if you are having code that is only exported for a test. Now, what do I mean by that? So let's go back to this initial made-up example, and let's assume we want to write a test for our great build name function, right? So what happens probably is that we're going to write an export statement in front of it, and then have a test file and import it there. But the problem is that in production mode, all the test files are excluded, so Knip would report on this one export as being unnecessary, because it doesn't see the test file. I think the best thing we can do here is to not test implementation details, because the build name function is not exported. It's a local file, and we should instead focus our tests on what actually gets exported, which would be this greeting component. But yes, in existing code bases where this has been done a lot, I think this can be quite annoying. So you can also tell Knip to basically shut up by adding another JS document, add internal, because this will mark the export as not meant for public consumption, but only for internal usages such as tests. and it will not be reported in production mode. It would still be reported in the regular mode. So this doesn't prevent cleanup, which is actually good. Now, apart from influencing how we work, we've also run into some interesting technical limitations. The first one is about dynamic imports. They generally work well, but there are some cases where Knip might not fully pick up on a dynamic import. One of them that we had was this import, where we were awaiting it and then we were destructuring it one line below. Now this is totally fine in JavaScript and TypeScript, but Knip doesn't keep track of where this mod variable is actually used. For performance reasons, it only looks at the dynamic import statement. So this code actually showed the modal CSS as unused, and there was a false positive, which I only noticed after I've removed a bunch of code, and then I got lots of TypeScript errors. But the fix here is obviously just refactor this and like remove this layer of indirection, which I wasn't really sure why we had this in the first place, but this is just something that the Knip won't pick up on. And we had a similar situation inside one of our entry points, where we have a dynamic import, but we don't await it. So we trigger the promise early, we then have some conditions, and then we conditionally await it later. So again, here Knip doesn't pick up on that, and I didn't want to actually change that code at all, because this is like very critical path. So the fix here was to just add this Sentry bootstrap initialize main directly to the list of entry points. That is something that you can always do. If Knip doesn't find something, you add another entry point, and then it will continue the flow down there. And lastly, I also managed to delete some code that I shouldn't have because of some highly dynamic things that we do with require.context. If you don't know what that is, that's a Webpack specific feature that allows you to basically import a whole directory based on a regular expression. And it then does some compile time magic to actually require all individual files. Now, Sentry was doing this in one of the code base, one of the parts where we were like importing this Sentry data forms directory, which I didn't know about. And in this directory, some of the things showed up as unused. So I thought they were unused and deleted them. And turns out then I deleted some forms. That wasn't so good. And of course, the fix here was to also add like Sentry data forms as an entry point, because Knip doesn't pick up on this require.context either. But I think it's also worth mentioning that I'm not really a fan of code like this. So this is way too dynamic also for developers. You can't even try to find usages of something if you require it like that. And I think if something is hard to statically analyze, it's probably also hard for humans to understand. So we are going to probably refactor away from that anyways. All right. Lastly, I have some stats as well. Because all in all, I made over 50 PRs because we like to trim things down to not notify all code owners at the same time. And it took almost 6 weeks to get through that. But what do you think, how many lines of code could we remove with Knip? Remember that Sentry has about 1 million lines of code. What do you think, how much of that was unused? 20%? That would be great. No, that would be a lot. Not quite. Okay, yeah. Good. It was 20,000 lines of code. So somewhere in between of that. That was almost 2% of the whole code base that was just lying around unused. All right, so if you want to try out Knip, it's as easy as running npx knip on your code base. See how far you can get without any configuration. It will likely show you some good stuff. And if you see some false positives, just add some configuration, and then you can declutter your code base to one Knip at a time. Thanks.
So thank you very much, Dominik. We have one question.
Okay.
So
I'll just read that. What if I want to leave certain code in place even when it's not used? Types for component props. I don't know why I would want to have code that isn't used. So I usually say, you know, we have Git for this, so you can always like look into the past, what was there. I would just remove it. You can always annotate it with @public or something like I've shown, then it just, you know, stays around. You have a comment as well that tells other people, don't delete this, we need this. I don't know what the types for component props, what that refers to. Because if I have a type and it's used in the component, then the type is used. So I don't know why I would have an unused type. But whoever asked that question, maybe we can talk about it afterwards. All right.
One more question.
Can it auto-delete the code? Yes. So there is an auto and minus fix that you can pass to it. It used to be experimental. I'm not sure if it's still experimental. I'm not doing it. So I was. I don't know. I also don't auto-fix linting in CI. You can do it locally, but locally, you know, unless you're about to delete code, you don't really produce that code that much, I think, when you write it. But it's good that there's also work being done in that direction, just to automate more stuff. I think that's good.
Okay, any questions from the audience? Okay.
Yeah.
Thank you. Can Knip be used for circular dependency analysis in the code?
For what, sorry?
Circular dependencies.
Circular dependencies. No, I think there are different tools for that. I know that I think Medge is a tool that does this quite well. It's an interesting question. We'd have to ask Lars about this because, I mean, it parses the stuff and then it stops. I mean, it doesn't die on circular dependencies because we have some and it still works. So it must somehow short circuit the whole thing if it finds a circular dependency. So maybe that's something that it can also like do in the future. It doesn't do it right now.
I saw there was a question right there.
Yeah, I had a question. In presentation, I saw that Knip works on workspaces, so I assume it supports cross-package checks. Does it support cross-package checks? For example, let's say I have two packages in my Yarn workspaces.
Yeah.
One is for types, and everything is exported there. There is no unused types there. But then I have my second package that imports those types.
Yeah.
And that first package is private. It's only inside my workspace.
Yeah.
I do not release it to NPM. So can it check cross-package that some types are actually unused in types package?
Yep, it can. So in Sentry, we don't have a monorepo, but I've used it on monorepos in the past. What it does per default on a package is it doesn't include the package entry point in its analysis. Right, so if you have a private package and you have like one entry point that's an index TS file, that's like a barrel file that exports a bunch of things, you know, if you write a library and you publish that, you probably don't want this to be analyzed because this is your entry point, your consumers use this, even if it's unused in your code, you want this to be in there. So the entry point like that in a workspace isn't linted. But you can, on a per package basis, you can configure it with something that's called, I think, include entry points, like a flag. And once you do that, it will lint those. So if you have a private package, at Adverity where I worked before, we had like, I think, 20 packages, and all of them were only for internal structuring. So it's great to know that if one package that imports it from the other package and you remove the last usage, you also get that this is now unused in the other package. So yes, that works if you configure it a little bit like that. Because it needs to know which package is like internal, basically, and which package is like a public one that you want to publish.
Okay, any other question? So I think that's it. Can we give a huge shout out to Dominik?
Thank you.
Thank you very much.